No, I'm not losing my voice. Human beings do that, not me. I fall in holes, throw trash all over myself, and then shake Gatorade up all over me. But nothing happened yesterday. All right, so I'm on page 37. This is a completely different topic that has nothing to do with the things we have studied before, except for the fact that this has to do with the derivative. The whole unit is applications of the derivative. They're like disconnected topics, and I think sometimes it gets a little confusing. My prediction is that you all are really going to like this and it's going to go well. That's my prediction. Jackie, if you could turn the camera some over here. Okay, up until this point, everything that you guys have looked at, pretty much everything, has been explicitly defined. I haven't even used the phrase explicitly defined, they just have been. For example, I've told you things like y equals x squared plus 6x. I've said f of x equals arc tan of x. I've said h of theta equals e to the theta squared. Explicitly defined just means you've got your dependent variable expressed in terms of your independent variable. That's the technical definition. This is the dependent variable. Y depends on the x. Y is expressed in terms of x. Okay, some students kind of think about this as like being calculator ready, meaning I could just go and type this expression into the calculator and be done. Everybody okay? Mm-hmm. That's explicitly defined. Implicitly defined, and this is really the focus of where we're going to be for the next 2 days. Implicitly defined is going to be expressions that look like this one. X squared plus y squared equals 6. The x's and the y's are mixing together on the same side. E to the xy plus the square root of y equals 2x. The sine of x plus the square root of y minus the square root of y equals 8x to the y power. I make stuff up. Making stuff up. Explicitly defined is what we've been doing this entire course. Everything is y equals. And I could ask you guys to find the derivative, and I know everybody would just take like 2 minutes and could find all three of those derivatives. Take 2 minutes, go find those derivatives. All three of them. 2, 5, 9, 12, 15, 17, 18.
Well, no, square root of 1 plus x.
1 over 1.
And e theta squared.
No, it's arc times. That's tangent. Arc tan to the 1.
I think he's got, but he said it was on
1 plus
He did?
square root x squared. Yes. Yes. I bet you it's 1 over 1 plus x squared.
Oh, I love it. Now there's betting going on what the answer is. Okay, Jose P, derivative of the first one. What you got? All right, all the conversations need to end. So 2x plus 6 is the derivative on the right-hand side. And everybody's got that? What about the derivative on the left? What do you write to indicate that you're taking a derivative over here?
Y prime.
Y prime. Everybody good?
Yes.
Name, how about the next one? Oh, sad panda. My other Jose, help me out.
1 over 1 plus x squared.
1 over 1 plus x squared. But what do you write over here? You write f prime of x. You're always taking the derivative on both sides. Always, 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 always. And how about this last one? Kaylin, how are you feeling with this last one?
H prime of A.
H prime of theta.
Theta equals e to the power of theta squared.
E to the power of theta squared. I love it.
Keep going. Times.
That would be good. What?
Times 2 theta.
Times 2 theta because of chain rule. Everybody good?
Yes.
That's explicitly defined curves. That's how you find derivatives of explicitly defined curves. Implicitly defined curves, this is where we're going to spend the rest of today and tomorrow, and you're going to love it. Love, love, love. And I think here's part of why you're going to love it. Implicitly defined curves are pretty. They are these beautiful little graphs, and I want to be careful. I need to call them implicitly defined curves, not functions. Curves, not functions. Why curves, but not the word functions? Implicitly defined curves, but not functions. I am not going to use the word function Nor will I let you use the word function. Beto, why?
Because it fails over, for example, the vertical pencil testing.
The horizontal, vertical pencil test thing. Does anybody else know what he's talking about?
The vertical
You guys have been
line
together for a long time, Jackie. It's the
test. Vertical line test.
vertical line test. The vertical line test says if I ever can draw a vertical line and it crosses the curve more than once, not a function?
Yeah.
We're good? So implicitly defined curves. Now let's check this out. The ellipse, 16x squared plus 9y squared equals 144. X's and y's mixed together on the same side.
Yeah.
We know what the graph looks like. This guy over here is called the bifolium. What's the word?
Bifolium.
Bifolium. I like to think it's like half of a butterfly. Somebody always sees it, they're like, oh, it's pretty, it's half of a butterfly. And then some guy in the class is like, yeah, where's the other half? It ended badly for the butterfly. The bifolium makes this like half a butterfly. You've got the rotated hyperbola, and then the last one, the word is limaçon. Limaçon. Say it like you speak French. Limaçon. With attitude. Limaçon. Limaçon. Good. All right. All four of these are implicitly defined because the x's and y's are kind of mixing together on the same side, and you make these beautiful, beautiful curves. Curves, not functions. What I want to do is we're going to explore the calculus of working with implicitly defined curves. I think you guys are going to be okay. One of the reasons why I think students like this so much is that there's not a lot of word problems here. There's not a lot of geometry that you're going to trip over. It's just a process that you go through. So here we go. This first one, x minus 3 squared plus y plus 4 squared equals 25. For those of you that like processes, I got really creative with my smart art graphic, and it's all right there what we're going to do. Okay, x minus 3 squared plus y plus 4 squared. Some of you might know that this is the graph of a... Go back to pre-calc. What do you know? X minus 3 squared plus y plus 4 squared equals 25 is not an ellipse. No. It's a circle. Not only is it a circle, you can hopefully tell me where the center is. The center
3, -4.
is at 3, -4, and you should be able to tell me what the radius is.
4.
The radius is 5. Okay, Mr. Lake is throwing up somewhere. He doesn't know why. Nobody remembered that the general form of a circle is x minus h squared plus y minus k squared equals r squared. Don't worry, if you didn't remember, you'll still be okay. Just Mr. Lake is pissed off and he doesn't know why. All right, I want to find dy dx for the circle defined by that equation. Dy dx, you guys know, is derivative. Here we go. Ooh. What? Oh, we were blessing. Okay. We're very religious here in Texas. Okay, x minus 3 squared plus y plus 4 squared equals 25. We're going to find a derivative. And pay attention, you're going to be just fine. X minus 3 squared. I want to take a derivative over here. What derivative rule do I need? X minus 3 squared. Chain rule. Chain rule says 2 times x minus 3 to the first power times the derivative on the inside. And the derivative of the inside, everyone's going to tell me is 1 plus derivative of y plus 4, the whole thing squared. Another chain rule. 2 times y plus 4 to the first power, just like over here, times the derivative of the inside. Not 1. When we write the derivative of y, it's not 1, like over here where I said y equals x squared plus 6x. You guys said, oh, derivative is going to be y prime. Nobody said 1 equals 2x plus 6, because we knew we were taking the derivative of y, and that's special. It's the dependent variable. So over here with the chain rule, I'm going to say 2 times y plus 4 to the first power times the derivative of y, which is y prime. Derivative of 25, 0. Basically, when it comes to implicit differentiation, when you find the derivative of the y expression, dy dx. Now, last class period, a whole lot of folks were like, yeah, I'm good, I know what to do. I want to caution you against using y prime. Big mistakes happen here, especially with sloppy students. Sloppy students are going to see y prime and they're going to think y to the first power. So rather than writing y prime, this is why I'm going to use dy dx. I want it to be clear. We found the derivative, but y prime, you're going to blow it. Somebody's going to get this wrong. The goal is to find dy dx. And before you box it and be like, there it is, I found it. I mean solve for dy dx. I want to solve this equation for dy dx. Dy dx is all by itself. What I need, I have the onion. I just need some algebra. Some algebra to get dy dx by itself. Like maybe you want to clean this up and say, okay, this is 2 times x minus 3 plus 2 times y plus 4 times dy dx is equal to 0. I want to solve for dy dx. This whole expression has dy dx. This one doesn't. A good algebra move that to the other side. So I'm going to say that 2 times y plus 4 dy dx is equal to the negative of 2 times x minus 3. I still need to find dy dx. So my next algebra move, it's the legal algebra that I can do here to get dy dx by itself. Divide. Negative 2 times x minus 3 divided by 2 times y plus 4. If you want to clean it up by canceling out the 2's, that's great. Dy dx, your derivative, is the negative of x minus 3 divided by y plus 4. That's it. That's your answer. That's what you're looking for. You want the derivative. We can do this. We can totally do this. Now, if you look closely at this answer, it might look a little strange. Anything strange about it? We've got a y in our derivative. We don't normally have a y in our derivative. Normally, we just have one variable. When it comes to the world of implicitly defined curves, because you have the x's and the y's kind of mixed in together, usually your final answer is going to be in terms of x's and y's, and that's okay. We're going to deal with the 2 variables. Finally, Abraham, 2 variables at the same time. Everybody okay? All right, let's keep going. Part B. Using your expression from part A, what we just did, determine the location of horizontal tangent lines. When you're done, use the graph to confirm that that's actually correct. Horizontal tangent line. Anybody know anything about horizontal tangent line?
No, I'll tell you the 2.
Horizontal tangent line. There's something everybody needs to know about a horizontal tangent line. What's equal to 0?
The derivative.
The derivative. So if you're looking for a horizontal tangent line, dy dx is equal to 0. Look at the graph for a second. How many? How many horizontal tangent lines? 2. Right? One at the very top, one at the very bottom. If you were given the graph, Jesus, I would hope you'd look and be like, oh, I know what the point is. What are the coordinates here? Was it 3, 1, and then down here, what is that? 9, 3. What?
9.
3, negative 9. That's all right. It's all right. It's all right. Okay. Here's the thing. If you have the graph in front of you, these questions are easy. College Board, not going to give you the graph. I'm giving you guys the graph today just so you can feel good about yourself. And then I can take it away. Eric, you okay? Just taking a moment to pray. I understand. Very religious here. Okay, so what we know is that dy dx is equal to the negative of x minus 3 divided by y plus 4. And I need that to be 0 because I want a horizontal tangent line. You have a fraction equal to 0. What has to be true? My derivative is a fraction. It's equal to 0. What has to be true? For a fraction to be equal to 0. Just bet them. Bet you help me out. What do you got?
The numerator has to be equal to 0.
The numerator, the top of the fraction, has to be equal to 0. We okay? But I want to be really specific here. It's the negative of x minus 3 is equal to 0 but the denominator cannot be equal to 0. Because if the top is equal to 0 and the bottom is equal to 0, your fraction is not equal to 0, it's an indeterminate form. Okay, easy peasy. The negative of x minus 3 is equal to 0. Distribute if you want to. Negative x plus 3 is equal to 0. Negative x equals negative 3, so x equals 3. I want the coordinates for the point or the points. Coordinates are always going to be like 3 comma something. I've got the x, I don't have the y. And you can't go to the graph. You've got the x, but you need the y. Plug in where? To the derivative? To the original. Love it. Back to the original, because this is what connected the points together, the x and the y. So let's do it. X equals 3. So that means 3 minus 3 squared plus, what is it, y plus 4 squared is 25. 3 minus 3, no surprise, 0. So y plus 4 squared is equal to 25. If y plus 4 squared is equal to 25, then you guys can all tell me what y plus 4 is equal to. Don't say 5.
1.
Oh God, don't say 1. Y plus 4 squared is equal to 25, so y plus 4 is 5. I agree, half right.
Oh, the negative number positive.
What squared is 25? Positive 5 and negative 5. So you have to solve both. So you say, oh, that means that y plus 4 equals 5, or y plus 4 is equal to negative 5. If y plus 4 is equal to 5, then y is equal to 1. If y plus 4 is equal to negative 5, y is negative 9. So your answers are 3 comma 1 and 3 comma negative 9. And guess what? Those are exactly the places where we saw the horizontal tangent lines from the graph. So it's true. I'm not lying to you. I'm not making up calculus. I'm trying to give you, although I could. Totes could. Totes could. I'm going to withhold the graphs most of the time because I need you to do the calculus behind this. Yeah. Okay. See what you guys can do at part C. Yeah. You want to keep it? No, right.
I was stretching.
Yeah, it's the same thing. Totes the same. Alright, homework pile over here. Okay, homework pile over here. Okay, homework pile over here.
Y equals 0.
Homework over here.
Yeah.
Thank you, Dick.
I always read it. Yeah. Every time I read it, that's everyone's been asking me. I just read it.
Using your expression from part A, dy dx, Jose, was it negative of x minus 3 over y plus 4? Okay. Part C, vertical tangent line. Vertical tangent line. You guys know what that looks like? What does that look like? Looks like this. For this graph, how many vertical tangent lines? I can see it. Right here, there's going to be one. Right here, there's going to be one. If I needed to give me the, if I need you guys to give me the points, what are the coordinates?
8, negative 4.
8, negative 4,
And negative 2.
and negative 2, negative 4. That would be the too easy for you all question. I give you the graph. I won't give you the graph. If I have a vertical tangent line, you guys know about the slope. What's true about the slope at a vertical tangent line?
0.
Not 0, that's horizontal.
Y equals 0.
Vertical tangent line. Vertical tangent lines are bad for us. Dy dx does not exist. or dy dx is undefined. Okay, I think I heard Kevin in the back say, like, all right, this doesn't exist. Why would the derivative not exist? Derivative's a fraction. Why would a derivative not exist? The denominator equals 0. But, be specific, the bottom's equal to 0, but the top's not equal to 0. We want to avoid being in this 0 over 0. Okay? Well, let's finish it off. Y plus 4 is equal to 0. That means that the y coordinate is -4. Oh my God, totally matches the graph. Good. Go get the x value. Where did the x values come from? Plug it back in. X minus 3 squared plus, I'm careful right now. X minus 3 squared, 0.
Say nothing yet.
Huh?
Oh, nothing.
X minus 3 squared is equal to 25, so x minus 3 equals plus or minus 5. If x minus 3 is equal to 5, x is 8. If x minus 3 is equal to -5, x is -2. We get the points 8, -4, and -2, -2. And I hope everybody's okay. The calculus supports the graph.
Yes.
Is that a 5?
That's a messy, this guy here?
And the one up there? Like,
Yes. That's a 5 as well. Okay. I think we're mostly okay. I can't wait to grade all of your papers later. Y is -4.
Wait,
This
is
should
it
be
supposed to be -2/4? Okay.
-2, -4. Yeah, thank you, Ashley, for being the one to know. Just shh. You're like, I don't care enough. No. Okay. I think everybody's mostly okay. So you guys are ready for a challenge?
No.
No. We're the DeRosiers. We're ready for a challenge. I was. You were. Here comes your first free response question. This question would be worth 9 points on the free response part of the exam. The day of the AP exam, 180 days from now, you'll do 45 multiple choice questions, and then you'll do 6 free response questions. Life is going to be good. Okay. So here we go. Just leave it on my desk. Naomi, it's really not this difficult. Okay, the equation is y to the 4th plus x equals x cubed minus xy plus 2. The graph is provided, will not be provided by the College Board. And I want you to show me that the derivative is equal to this expression over here. How kind. They're even telling you what the goal is. You just need to get there. So why don't you have a quick strategy conversation with the folks around you? What are you going to do? I have faith in your smart particles.
Make this
Well, are we
into
supposed to
what
run for the
you
horizontal thing?
make this into what you
How did that become a
Trust your smart particles.
do subtracting it.
Oh, wait, it's from the derivative, huh? Oh.
Divide this by what you
Why do you have this actually?
Yeah.
I had that video.
The y cubed. Dividing, how would you subtract it? So before minus 2, that is y to the first. So,
It's not like.
Oh,
this shit was this big, right?
okay, so they gave you the curve. They want you to show that this is the derivative. Most groups have started finding the derivative. All right, let's find the derivative. What's the derivative of y to the 4th? 4y cubed. However, you have to be careful here.
This is the 1.
You're taking the derivative of a y expression. So it's 4y cubed times dy dx. And if you didn't see where that just came from, that's a chain rule. You're looking at the derivative of y being raised to the 4th power. Y depends on x. So it's 4y cubed times the derivative of y, which is dy dx. Okay, stay with me. Plus derivative of x, 1, equals derivative of x cubed, 3x squared, minus the derivative of xy. Hold for a second. Derivative of xy. Some of you took a deep breath. You just realized you're going to have to do something here. You're going to want to rewrite this. You need product rule. Okay, now here's the thing. I'm just going to write it this way. I'm just going to say the derivative of xy. Like, I'm not ready to actually find this derivative yet. We've all agreed product rule, but I want to pause. Good with the derivative over here? This guy, this one's going to take some work. Plus the derivative of 2.
0.
What?
0.
0. My God.
Who's the next?
Okay. The work for us is over here at the product rule. Take 30 seconds, go get that derivative for me. I want to be a proud papa. Go find that derivative. Use your product rule skills. Product rule, derivative of the first, leave the second alone, plus the first times the derivative of the second.
So it would be 1 plus x.
If you're going to do this well, product rule, derivative of the first is 1. Times we leave the second one alone. Plus, now you leave the first one alone, times the derivative of the second, which is y prime, but we're not going to say y prime. It is y prime. I just want to avoid this confusion that you're going to have. So check it out. 4y cubed dy dx plus 1 equals 3x squared minus the derivative of xy. Here is the most lethal mistake you guys are likely to make. This was supposed to be 3x squared minus the derivative of xy. The derivative of xy is all of this stuff here. Meaning you need the parentheses so that you remember to distribute. If you don't have the parentheses, I think it is likely you won't remember to distribute. Alright, so 4y cubed dy dx plus 1 is equal to 3x squared minus y minus x times dy dx. That would get you the first point. We're so not done. We're done with the calculus. And here's the problem. You want to solve for dy dx. That's not calculus, this is going to be algebra. And I think you guys are going to get caught off guard by the algebra. Where's dy dx?
On both sides.
dy dx is here, and it's over here. They're not going to cancel out. You need to think like an Algebra 1 student. The variable that you want is on both sides of the equation at the same time. Wouldn't you want? Sorry, it's an asthma thing. You don't want necessarily want to subtract the smaller. The problem is they're on different sides. Get them on the same side. And you might be like, why would I do that? You'll see. So just algebra. 4y cubed dy dx. That's that term. This guy's on the wrong side. Fix it. We're going to add it. X dy dx. Okay? Equals everything that doesn't have a dy dx. So 3x squared minus y minus 1. And if you're paying attention to your goal, it might start to come together. Look at your goal. Look at what you're trying to show them. You need to show them that dy dx is 3x squared minus y minus 1. I've got that. Divided by 4y cubed plus x. I kind of have that. The algebra piece that you need, you can not cancel, factor. Thank you. I do look good today. I can take that dy dx and factor it out in front. Times 4y cubed plus x equals all this stuff. So finish it off. What's dy dx equal to? 3x squared minus y minus 1 divided by 4y cubed plus x. And that's where the second point would come in. It's a whole lot of sneaky algebra. I'm going to continue to push you guys pretty hardcore on the algebra. So that's part A. 2 points.
That's part.
Dos. Out of 9. 7 more to go.
So much work.
Yeah. So, last class, Sylvia asked the question. She was like, but wait a second, what if I make a mistake? What if I get, don't write this down. What if I write 3x squared plus y plus 1? And then I move on to part B, and I use my wrong answer. Will I still be able to get points?
Yeah.
No.
What?
No.
Equations of
In this case,
they gave you the
today, this moment, this problem, no. Because they told you what the derivative was.
in writing.
For Sylvia to be like, well, I get this one, I'll use this one for the rest of the problem. Not the smart move. Everybody okay?
Yes.
All right, so we got all that. I want to see what you guys can do with part B. Trust your smarticle particles. I have trained you all well. You know what to do with this one. No. I mean, there might be sometimes, but don't worry about that. Part B. I need the equation of the tangent line at 1, 1. I think at this point in the course, I've asked a question like this 50 times.
Yes.
Equation of the tangent line. Everybody knows what to do here.
May I? Sana Mr.
I hate what he's doing. Can you?
If you're going to write the equation of a tangent line, you need the point, you need the slope. They gave you the point. Where's the slope coming from? Where does the slope always come from? The derivative. So what you need for the slope, and I'm going to write it this way, you need the derivative. Okay, all the side conversations are going to stop. You've got to find the derivative at the point 1, 1. Up until today, whenever we've gone to the derivative, we just need an x value to plug in. Now, because your derivative involves x's and y's, you need to plug both in. Okay? So we can do that pretty quickly. And what is that? 3 times 1 squared minus 1 minus 1. 4 times 1 cubed plus 1. Simplify if you want to. What are we going to get if we simplify? 3 times 1 squared minus 1 minus 1. I think that's 1. 4 times 1 cubed plus 1 is going to be 5. That's the slope. Congratulations, you picked up the first point. I need the equation of a tangent line. You shouldn't even have to stop and think. Kevin, you get this one? L of x equals what? 1/5. X minus 1 plus 1. Nice, we're up to 4 points. Once you've got the derivative, you're just going to start using the derivative in new ways. All right, part C. Determine the concavity of the curve at 1, 1. Last class they thought, oh my God, so easy. 1, 1, I look at the graph, what's the concavity?
Concave.
Oh my God. Concave up.
But we won't have a graph, right?
They will never give you the graph, and I won't give you the graph either. Today, while we're like developing the skills, I'll give you the graph. But how do we figure out concavity if you don't have the graph? Not the derivative. What do you need, Abraham? Second derivative. Oh my God, all the teeth sucking today. I must be doing a good job. I need to determine the concavity, which means go find the second derivative and figure out if it's positive or negative. If your second derivative is positive, you're all going to tell me. Second derivative is positive. So the function is what kind of concavity? Concave up. Second derivative negative, concave down. So good. All you need now, and I'm going to write it this way. D squared y dx squared. Second derivative.
Huh? Is that supposed to be dy squared?
No, it's d squared y dx squared. It just is. Suck your teeth.
Really?
There you go. Yep, that's it. The second derivative. This is the notation for second derivative. D squared y dx squared. Great. Go find the second derivative.
Yes, sir. We have a dilemma. Not a dilemma, problem. Maybe that t second instead of t second. Because t second will be like.
I don't care. Second
You
derivative.
told me to ask him.
Hey, giggle girls. Teeth sucking, lip smacking, I don't know. Get to work.
They call me teeth sucking.
Okay, it looks like just about everybody is doing quotient rule. Quotient rule should be obvious here. Quotient rule, a little low, D high. So low, D high. Need the derivative of the high. 6x. So derivative of 3x squared is 6x. Minus the derivative of y? dy dx. Because you're taking the derivative of a y. So it's 6x minus dy dx minus derivative of 1. That's 0. I want to really encourage you guys to put parentheses because you need all of this times all of that. Yeah.
Separate dy dx, like we put the actual derivative.
Hold that thought. Hold that thought. Low D high? We're good? Minus high.
Below.
3x squared minus y minus 1. D low. Was that 12y squared?
That long?
Dy dx plus 1. Low D high minus high D low. All over. Low low. If you successfully found that derivative, 2 points
Plus 1? Yes.
is what necessary.
Plus 1?
Yeah. Okay. Here's the problem though. No one's done. You're not done until you can tell me about the concavity. To get the concavity, you have to plug in. You've got to figure out, is this positive or is it negative? So let's do it. D squared y dx squared at 1 comma 1. We're going to have to do some math, like simplifying kinds of math in ways that we don't normally do. 4y cubed plus x. They're kind. Y is 1 and x is 1. Okay? So 4 times 1 cubed plus 1, you guys can all tell me is 5. 6x. 6 minus dy dx. I want to come back to that. I'm just going to write dy dx. Minus, next one. 3x squared minus y minus 1. 3 times 1 squared minus 1 minus 1. 1. Times 12 times y squared, 12. Dy dx plus 1. All over 4 times y cubed plus x. Is that 5 squared?
Yeah.
We have to figure out if this is positive or negative. And there's a mystery here. What's dy dx?
Don't you just plug in 1 to the first derivative?
Okay, so I hear Jose saying, and Roberto, this connects with what you said earlier, we know what dy dx is.
Yes.
So what's dy dx at 1, 1? Juan, you did that so quickly. How did you get dy dx as 1/5?
Oh, because if we're in the B.
We already did it in B. All right. So that's a 5th. That's a 5th. Getting there is your 3rd point. And we're almost there. We're almost done. We're ready to land the plane.
Are we ready?
Are we ready to go?
Takes over.
The issue is this positive or is it negative?
Either or.
It's one of them. You think positive. Juan's actually 100% correct that it's positive.
But why don't?
Do you know why it's positive? Do you know why this is positive? I love it. If you solve it out, it's going to come out to be like a positive number. You actually have to convince me with your math skills that this is positive. So I hear you saying, like, distribute the 5 through, guys, stay with me. 5 times 6 is 30, minus 5 times a 5th. Oh my God. 12 times a 5th? That's 12 fifths. Plus 1? 12 fifths plus 1 is 17 fifths. So this part over here is 17 fifths. You've got to distribute that through. Divided by 5 squared, which is 25. 30 minus 1 minus 17 fifths. All I need to be convinced about is positive. And if you're not 100% sure, 17 fifths is like 3 and a little bit. 30 minus 1 minus 3 and a little bit has to be positive. Divided by 5 squared is positive. Your conclusion? Concave up. I'd say something like the curve is concave up where? At 1, 1. Why? Because second derivative is positive. Hi there. Jackie is here. Okay, we're just gonna move on. Told you about the teeth smack. Okay. All right. So here's what I want you guys to do. We get about 5 minutes while we contemplate what's actually happening with Jackie. Okay. No more TV time at the DeRozier house. Let me tell you. Okay. There are 6 problems on page 40. You're not going to complete all of them. There's no way. Goal is at least knock out 2 or 3 of these. I've already sent you the solutions. This will be helpful when you're working on tonight's homework that's due tomorrow. You guys should be able to bang out the first 2 in like moments. Go for it. I'll be here now. Where are you going to be? Oh, you know what? Same place.
You have
Oh, how do you know?
Yeah.
Okay, that's one. Hey.
The list is like what, 3?
That's it, right?
All these new campuses that have graduated.
Problem number 1, you should be done with already.
Can you tell me the answer?
All I know today, English is going to be amazing. I'm full of energy.
Yeah, you guys tell us something today. So the derivative 9y squared plus 2y dx, I'm sorry, times dy dx plus 2x is equal to 0. Solve for dy dx. dy dx is going to be, I'm going to subtract the 2x, and I'm going to divide by the 9y squared. That is as easy as these are going to get. There is no easier problem. That's the easiest one. Okay, let's get out of number 3. Natural log of x squared plus y squared equals x plus 4.
Can't you do something with the exponent? Can't you separate it?
Nope. They're not the same variable.
Break it down.
Oh, you're talking about number 3?
1 over x.
So number 3, natural log of x squared plus y squared equals x plus 4. There are no properties here. No, there's no properties for when you're adding logs. There's properties for if you're multiplying inside the log or dividing or powers, but not addition. So we need to find the derivative of natural log of stuff. And you guys all know that derivative of natural log of stuff is 1 over stuff times derivative of the stuff. All right, let's do it. Derivative of natural log of x squared plus y squared is 1 over the stuff times 2x plus 2y. We just took the derivative of something with a y in it. Times dy dx. And we've talked about this a lot. You're multiplying both of Delia. Hi, can you turn around focus on me? That would be nice. 1 over x squared plus y squared times the derivative of the stuff equals derivative on the right. The derivative on the right is 1. Now, here's the thing. Your goal is to get dy dx by itself. You got to solve for dy dx. All we need is some algebra. You could do the onion method, like we're going to undo things. How about if we do this? 1 over x squared plus y squared times all this equals 1 is the same. What if I divided both sides by 1 over x squared plus y squared? Okay, hold on a second. If I divide both sides by 1 over x squared plus y squared, those guys cancel out? 1 divided by 1 over x squared plus y squared is the same as x squared plus y squared. So 2x plus 2y dy dx equals x squared plus y squared. You have to solve for dy dx. Careful with your algebra skills here. Get dy dx by itself. You have to subtract the 2x to the other side first, and then divide. So x squared plus y squared minus 2x divided by 2y. Tonight's homework is assignment number 61, rounds 1 and round 2. I've already emailed the solutions to you guys for all of these practice problems if you need extra help. I'm not available today during lunch, sorry.
Why? I need you the most, you leave me.
Right, that's me.
Like,
Sir, yeah.